A solution of a system of linear equations in three unknowns is an ordered triple that we write as x, y, z in parentheses separated by commas. And it's a solution of each equation in the system. For example, let's find out if the ordered triple -2, 3, -4 is a solution of the system with the three equations 3x plus 4y minus 2z equals 14, 2x plus y plus 2z equals -9, and x minus y plus z equals -9. We need to know if this ordered triple is a solution to each of these three equations. Starting with the first equation, we have 3x plus 4y minus 2z equals 14. We'll substitute -2 for x, 3 for y, and -4 for z. That gives us 3 times -2 plus 4 times 3 minus 2 times -4 equals 14. Multiplying, we have -6 plus 12 plus 8 equals 14, or 14 equals 14. So the ordered triple is a solution to the first linear equation. Now let's look at the second one. 2x plus y plus 2z equals -9. We'll substitute -2 for x, 3 for y, and -4 for z. That gives us 2 times -2 plus 3 plus 2 times -4 equals -9. Multiplying, we have -4 plus 3 minus 8 equals -9, or -9 equals -9. That's also a true statement, so this ordered triple is a solution to the second equation. Now let's try the third. X minus y plus z equals -9. We'll substitute -2 for x, 3 for y, and -4 for z. That gives us -2 minus 3 plus -4 equals -9. Simplifying, we have -9 equals -9, another true statement. Since this ordered triple is a solution to all of the equations in this system, it is a solution to the system. Now let's look at how we can solve a system using the elimination method. To solve a system of three unknowns using the method of addition or elimination, we first want to eliminate one variable from any two equations. Then we'll eliminate that same variable from a different pair of equations. Next, we'll take those equations that we found in steps 1 and 2 and use them to eliminate a second variable, leaving us with only one variable that we can solve for. Finally, we'll work backward to solve for the other two variables. Let's try out this method with this example of three linear equations and three unknowns. I'll label these three equations A, B, and C so we don't get them confused. I'm going to start with equations A and B. Notice that if we add these two equations together, we can eliminate the variable y, since equation A has a positive y and equation B has a negative y. Adding them together, we have 2x minus x, or 1x, y minus y, or 0, and z plus z, or 2z, equals 9 plus 1, or 10. Now we need to repeat this process and eliminate the same variable, the y, using a different pair of equations. We can use equations A and C or B and C. Let's use A and C since they already have opposite signs, a positive y and a negative y. Adding these two equations together, we have 2x plus 3x, or 5x, y minus y, or 0, and z plus z, or 2z, equals 9 plus 9, or 18. Now we have two new equations with only two unknowns, x and z, and we can use these two equations to eliminate a second variable. Notice that if we just add these two equations together, a variable will not be eliminated. So we need to change one or both of these equations. Since both equations have a positive 2z, let's take one of them and multiply by -1 to change the sign. Multiplying the first equation by -1, we have -x minus 2z equals -10, and we'll leave the second equation alone. Now when we add these two equations together, the z variable will cancel out. we have negative x plus 5x, or positive 4x, negative 2z plus 2z, or 0, equals negative 10 plus 18, or positive 8. Dividing both sides by 4, we find that x is equal to 2. Now we can work backwards and solve for z and y. We can use either of our equations from steps 1 and 2 to solve for z. I'll take this one here, 5x plus 2z equals 18. Substituting 2 for x, we have 5 times 2 plus 2 times z equals 18. Multiplying, we have 10 plus 2z equals 18. And subtracting 10 from both sides, we have that 2z is equal to 8. Dividing both sides by 2, we have z is equal to 4. Now we can go back to one of our original equations with our values for x and z and solve for y. Let's use equation B, simply because it looks the simplest. Substituting 2 for x and 4 for z, we have negative 2 minus y plus 4 equals 1. Adding, we have negative y plus 2 equals 1, and subtracting 2 from both sides, we have negative y equals negative 1. Finally, multiplying both sides by negative 1, we find that y is equal to positive 1. Now we have our ordered triple. We have that x is equal to 2, y is equal to 1, and z is equal to 4. And we can state the solution set as the set containing the ordered triple 2, 1, 4.